Hey guys, this is the video for Chapter 1, Section 6, Average and Instantaneous Rates of Change. So what will we be covering here? We'll talk about average rates of change, we'll see what difference quotients are, and talk about instantaneous rate of change. Alright, so what is average rate of change? What is that? Well, it's given by this formula shown, right? So we talk about the average rate of change of a function over an interval. And what this is it is the slope between the points x1 comma f of x1 and x2 comma f of x2, right? So notice that's rise over run, change in height over change in x. And what we're doing there is we're just seeing how much the function had changed from x1 to x2. And we're averaging that over that distance. And so that's the change in y over x, rise over run, and it's the slope of the line through those 2 points. That's what the average rate of change is. It tells you how your function was changing over a given interval. So you take the change in height divided by the length of that interval, and that gives you that average rate of change. So let's do an example here. Let's find the average rate of change of f of x over the interval from 0 to 5, right? So remember that's f of x2 minus f of x1 over x2 minus x1. That's the equation for the average rate of change. So what we need to identify here is what is x1 and what is x2. So we look at this interval. So that tells you x1 is 0, that's where you start, and x2 is 5, that's where you end. So we're going to need f of x1 and f of x2. So f of x1 is f of 0. So that's 0 squared minus 3 is negative 3. And f of x2 is f of 5. And f of 5 is 25 minus 3, which is 22. So now plugging those 4 things into this difference quotient, we get 22 minus negative 3 over 5 minus 0. And that's 22 plus 3, which is 25, over 5, and that's equal to 5. So the average rate of change of this function from 0 to 5 was... Alright, so that was average rate of change. We'll move on to the difference quotient. What is the difference quotient? Alright, so let's start with talking about the average rate of change, which is what we were just doing over a function from x1 to x2. Right? So that's how the change in the height over the change in x from x1 to x2. Now we're going to write h as x2 minus x1. So that's the length of the interval from x1 to x2. Right? So we're going to say h is x2 minus x1. Then, using that equation, we can solve for x2 and get x2 is x1 plus h. So all that says is that if you start at x1 and go over by h, you'll end up at x2, because that was exactly the length of this interval was h. And so substituting that in there, instead of an x2, we'll say f of x1 plus h. And instead of an x2 minus 1, you get just h. And so we are just rewriting this average rate of change here as the change in height when you go over h divided by that distance h. All right, so again, we're rewriting the average rate of change as the change in the height from x1 plus h to x1, from x1 to x1 plus h, and then the change in the distance there, which is exactly h. Right, when you do that, and then instead of writing x1, you just write x, that is the difference quotient, right? So it's the average rate of change where you go from x to x plus h, where here h is just some distance. It can be any distance you like. Right, so that is the difference quotient. It gives you an average rate of change where you start out at the point x f of x and end up at x plus h comma f of x plus h. Right, so that's something you guys will have to remember, that is the difference quotient. So what this difference quotient is it gives us an equation for the average rate of change of a function between x and x plus h for any h we want. Right, so what we're going to want to do is, given a function, find that difference quotient, which will give us that average rate of change for any h we want, and simplify it and write it nicely. Right, that's something we'll be practicing and using a lot in the future. So let's do that here for this function. So remember, the difference quotient is f of x plus h minus f of x f of x over h. So here h is a constant. It's going to hang around. You don't have to replace it or anything like that. You do have to be careful about plugging in x plus h to this function, right? So for this function, whatever's inside these parentheses goes right here where this x is. So if it's an x plus h there instead of an x, then the whole x plus h goes right there instead of the x, right? So what does that look like? Well, that means f of x plus h is 7 times, and then again we put everything that's inside these parentheses wherever that x was. So what's inside there is an x plus h. So 7 times x plus h plus 2, that is f of x plus h. And then we're going to subtract, right, so that was f of x plus h. Then we subtract f of x, and for that we're just going to copy down what we started with. And then you divide that whole thing by h. So that is the difference quotient. So we found the difference quotient, but we also need to simplify it. So for simplifying it, we're going to have to distribute this 7 and then have some things cancel and see what happens. So we get 7x plus 7h plus 2 minus 7x. Right, so we're going to distribute this negative. We get minus 7x and minus 2 over h. And now notice that we have a plus 7x and a minus 7x, so those cancel. And a plus 2 and a minus 2, so those cancel. And you're left with 7h over h. And then you can cancel your h's and you just get 7. So that is the simplified difference quotient for this function. And what you should notice here is that in that numerator, all the stuff that did not have an h, like 7x, 2, the minus 7x, and the minus 2, that all canceled with something else in that numerator. And that will always happen. Right? When you are simplifying this difference quotient, the numerator should always cancel nicely, and the only stuff that you should be left with when you get to this step is things that have an h in them. And then you should always be able to cancel an h. So in this case, it was nice. We only had 7h in the top. If you had more than one term with an h in that numerator, you would have to factor it out, and then you can cancel that h. But that h in the denominator here should... So let's look at another example of that. Here we have 3 over x. So again, remember, it's the difference quotient, which is what we're trying to find here, is f of x plus h minus f of x over h. Right, so how do we figure that out? Well, we need to plug x plus h in. So again, remember, whatever's inside these parentheses goes right here where this x is. So this is 3 over x plus h minus 3 over x. And then that whole thing is over h. So there we have found the difference quotient, but we still need to simplify the difference quotient. So how do we do that? We have to be able to subtract these fractions. And remember, to subtract fractions, you have to have a common denominator. And so what we're going to do here is you go over to this x plus h guy here, and you're going to want to have that denominator become x times x plus h. So to multiply by an x on the top and make that legal, you have to also bring an x into the, to multiply an x into the bottom, you also have to multiply an x into the top. And then this x over here, we want that to also have an x plus h. So now those denominators are the same. But in order to multiply by x plus h on the bottom and not change anything, make it legal, we need to also multiply by x plus h in the top. Right, so we went to the guy that started out with an x plus h, and we multiplied by x in the top and the bottom. And we went to the guy that started out with just an x, and we multiplied by x plus h in the top and the bottom. And now that those guys have a common denominator, we can combine those fractions. So on the left, we get 3x minus 3 times x plus h from the right guy. And then we're combining that, so that's all over that same denominator, x times x plus h. And that's all over h. All right, so from here, we need to continue to simplify. So one thing we can do is we've got something, it's a fraction, divided by h. So instead of writing that as divided by h, we can write that as times 1 over h. And now that's easy to see that this h is just going to slide into the denominator next to the x times x plus h. So we can rewrite this as 3x minus 3 times x plus h over x times x plus h. Oops. So x times x plus h. And then that times h. So that h that was here slid into the denominator. And now, to continue simplifying, we'll multiply this negative 3 through, and we get 3x minus 3x minus 3h over x times x plus h times h. And again, just like before, notice that we have a 3x and a minus 3x, so those cancel. And those terms do not have an h in them, so they should cancel. All the terms in the numerator that do not have an h should cancel. When that happens, you're left with negative 3h over x times x plus h times h. You do not need to distribute that x times x plus h through, right? You want to leave that denominator factored. And then you can cancel this h, right, since it's a factor of the top and the bottom. And what you're left with is negative 3 over x times x plus h. And that is our simplified difference quotient. So whenever you have a function where it's a number over x, and you're trying to simplify the difference quotient, you always have to in this step, find your common denominator. So you go to the x plus h guy, multiply x in the top and the bottom. And you go to the over x guy, and you multiply by x plus h in the top and the bottom. Then that h that's in the very bottom will always slide into that denominator. You distribute everything in the top, and all the terms that do not have an h should cancel. Once you've done that, you factor this h out and cancel it with the one in the bottom. And then whatever you're left with is your simplified difference. So now let's start talking about instantaneous rate of change, right? We discussed average rate of change. And now we're going to talk about instantaneous rate of change. So average rate of change gave the rate of change over an interval, right? From, like we looked at, 0 to 5. Instantaneous rate of change is going to give the rate of change exactly at a single point instead of over an interval. So that's what instantaneous rate of change is. And the way we find that is we talk about the average rate of change over smaller and smaller and smaller intervals, and we are going to shrink an interval all the way down to a single point. And by taking the average rate of change and shrinking that interval down to a point, that's going to give us the instantaneous rate of change at that point we shrunk to. And so when you are thinking about these smaller and smaller and shrinking things, that should remind you a little bit of limits. And in fact, the instantaneous rate of change is given by a limit, and it's the limit as h goes to 0 of the difference quotient. Right, so remember, the difference quotient gave us an average rate of change from x to x plus h. So if we want the instantaneous rate of change at x, then what we're going to do is take that difference quotient, the average rate of change from x to x plus h. But if we shrink h to 0, then we're shrinking that interval from x to x plus h all the way down to just that x. And so that's going to give us the instantaneous rate of change at x. And just like before, we can interpret the instantaneous rate of change geometrically, where before with the average rate of change, that gave the slope of the line between these points. When we shrink down and take that limit as h goes to 0, this gives the slope of the tangent. All right, so let's find the instantaneous rate of change of this function, first at x equals 1 and then at x equals 4. So remember, the instantaneous rate of change is given by the limit as h goes to 0 of the difference quotient. So that's what we'll start with. And the way we are going to do this is to simplify this difference quotient. So good thing we've been practicing. Then we will take the limit and end up with an expression in terms of x. And then the very last thing we'll do is plug in the x equals 1 and x equals 4. All right, so let's start with simplifying this difference quotient. Since we have not yet taken the limit, and we are not going to until after we've simplified the difference quotient, we need to continue to write that this is equal to the limit as h goes to 0 until we actually take that limit. All right, so we have to continue writing this limit as h goes to 0 until we actually take the limit. So what we have is this is equal to the limit as h goes to 0, and now let's simplify that difference quotient. But hey, we already did that. Remember, that was the same example from before where we had 3 over x. And if you look at what we got negative 3 over x times x plus h. All right, so we already did all that work. So we can exploit that. And now we want to take this limit. And remember, with limits, what we want to do is plug in h equals 0. And now we have evaluated the limit when we do that. And so we don't have to write that limit symbol any longer. And if you plug in h equals 0, what you're left with is negative 3 over x squared. So that is the instantaneous rate of change of this function. But if we want it at x equals 1, what we're going to do is plug in x equals 1, and we get negative 3 over 1 squared. But that's just negative 3. So there's our instantaneous rate of change at x equals 1. And at x equals 4, we're going to plug in x equals 4, so we get negative 3 over 4 squared. And we'll just leave that as negative 3 over 16. So that's our instantaneous rate of change at x equals 4. All right, our last example here, it says if Tucker sells homemade pies for X dollars each, it says his, but Tucker's not a he. It should say her. Weekly profit will be given by P of X is negative X squared plus 25X minus 80. Right, so we sell we sell pies for X dollars each, and then the profit is given by this function, the weekly profit. So it says if Tucker is currently selling pies for $9 each and increases the price to $11, what is the average rate of change in the weekly profit? All right, so what we're doing is X is starting at 9 and going to 11. So that's the interval from 9 to 11. And we're looking for the average rate of change of this function over that interval. So what we want is f of the second guy minus f of the first guy over the second guy minus the first guy. All right, so I'll let you guys plug in 11 into this function and 9 into this function. And you should get 74. That was the end of 1.6. So there's the homework, and there's Sully playing with Duncan.